Welcome back, everyone. Today we're going to be eliminating the parameter in each set of these equations here. The difference between this video and the last is that this time we're using trig in our equations. This time we have cosine and sine, and we didn't have those things before. Now, that said, the idea of how we do it is pretty much the same. The goal is to get rid of t and write an equation that represents both of these equations, but that does not have t, the parameter, in it any longer. So what I'm going to do is I'm first going to rewrite these equations in terms of cos t and then in terms of sine t for the second one. So for the first one, if I subtract 3 from both sides, I get that 4 cos t is equal to x minus 3. And then if I divide both sides by 4, I get that cosine of t is equal to x minus 3 divided by 4, like that. And then I'll do the same thing for the second equation here. Originally, the equation is y equals 2 plus 4 sine t. If I subtract 2 from both sides, I get that 4 sine t is equal to y minus 2. And if I divide both sides by 4, I get that sine t is equal to y minus 2 divided by 4. And there we go. Okay, the next thing I'm going to do here is I'm going to put these into this equation, into the equation that cos squared t plus sine squared t is equal to 1. And the reason we're allowed to do this, even though we weren't given this equation in the question, is because this is a trig identity that is known to be true. This is one of the, in fact, this is the most common Pythagorean trig identity that there is. And so we can take this as something that we already know, right? So recall that this is the case, just in general, not just for this question, but overall in general too. So therefore, we would have x minus 3 over 4 squared, right? Because I'm subbing in this equation into the cos squared t plus sine squared t equals 1 equation. And then I'm going to take this equation and sub it in as well. We're going to get y minus 2 over 4 squared is equal to 1. And now I just need to expand and simplify that. So we're going to end up with x squared minus 6x rather, plus 9, and then plus y squared minus 4y plus 4, and that's all over 16, and that will be equal to 1. And then if I simplify that further, we're going to end up with, let's see here, we're going to get that x squared plus y squared minus 6x minus 4y plus 13, if we combine the 9 and the 4, is equal to 16. And then we can, I suppose we can subtract 16 from both sides and get that x squared plus y squared minus 6x minus 4y minus 3 is equal to 0. And there we go. That said, we also don't have to necessarily expand. If you just wrote x minus 3 in brackets squared plus y minus 2 in brackets squared is equal to 16, that is likely fine as well. That just isn't the fully expanded form. Okay, let's try this next one. What if x is equal to 2 cos t and y is equal to 2 sine t? Well, in this case, we can use the Pythagorean identity once again. We can also state that in this case, cosine of t is equal to x over 2, and sine of t is equal to y over 2. So therefore, if sine squared t plus cos squared t is equal to 1, which we do know to be true from the trig identity, that tells us that y over 2 squared plus x over 2 squared is equal to 1. That tells us that we're then going to get y squared over 4 plus x squared over 4 is equal to 1. That means x squared plus y squared over 4 is equal to 1, which means x squared plus y squared is equal to 4. And there we go. Now we have an equation where we've eliminated the parameter t entirely, and that's the whole goal. As always, feel free to leave any questions you might have in the comment section, and we'll see you for the next one.